Video number 129, multiplying or dividing rational expressions. This first example is going to be a division problem. And just to review from basic mathematics from back in the day when multiplying and dividing fractions, if we were to take a look at something like this. How about this? How about this? Just simply 50 divided by 2. Well, most of us know that 50 divided by 2 is obviously 25 because you're dividing 50 into two pieces. Another way to look at this is to take 50 and multiply it by half. So you can take, in other words, half of 50. So this is a real simple example as to showing you that dividing by 2 and multiplying by a half are the same thing. Well, as it turns out, if we were, let's go to some regular notebook paper here. If we were just simply to take this idea and move it along to something here, like 4 divided by 2/3. Instead of 4, divided by 2, let's divide it by 2/3. Well, look what the pattern is. Instead of, so we're going to divide by 2. Instead, we can multiply by 1 over 2. Well, here, you can divide by 2 over 3, or in other words, divide by 2 over 3 means multiply by 3 over 2. And that would give us either, now there's a cool way to do this. You either do 12 divided by 2, which is 6, or you can do 4 divided by 2, which is 2 times 3, 6. Okay, so there's just a little quick lesson in dividing fractions. We're going to use this strategy for this problem right here. We're going to take our original first fraction and change it to a multiplication symbol in the middle, and we're going to reciprocate. In other words, change places between the numerator and denominator, called reciprocal. Alright? Now the next step is to write this entire multiplication problem as one big happy fraction, because what you got here is this. You're multiplying two fractions together. Let's review. From way back in the day, whenever we did this problem, 5/3 times 7/9, we would just multiply across. 5 times 7 is 35. 3 times 9 is 27. Now, so therefore 8r cubed times 9r cubed is going to be this. Now what I've done is I've expanded. I changed the 8 to 2 to the third, changed the 9 to 3 squared, and then r cubed times r cubed is r to the 6th. Okay? Now in the denominator we have 6, which is 2 times 3. There's your 6. There's your 5 right here, and then you got an r to the first, r squared, which gives you r cubed. Then we're going to go ahead and reduce. There's three 2's up top and 1 2 on the bottom. That reduces to a 2 squared. There's 2 3's up top, 1 3 on the bottom. Therefore, this 1 3 cancels with one of those. Alright, you're left with 1 3. Then the 5 stays in the denominator, nothing happens here. And then r cubed, because you have r to the 6th over r cubed. So r to the 6th over r cubed is r times r times r times r times r times r over r times r times r. You're left with r cubed. So that's why we have this. Then you just multiply the 4 times 3 together, get you 12 over 5, so it's 12r cubed over 5. Or you could write it as 12/5 r cubed. This would be the polynomial version, and that's the way I have it expressed in the answer, although either one of these two is perfectly acceptable. Alrighty then. Let's move on to the next one. Now we're going to multiply two rational expressions. So what we have here, the best way to do these problems is to factor each expression like we did in video 128, and then we're going to look to cancel. As it turns out, this factors right here to x plus 2 minus 1. This one factors to plus 4 minus 1. This one goes to plus 3 plus 1. This one goes to plus 2 plus 1. What happens is the minus 1's cancel, plus 1's cancel, alright? Then your plus 2's cancel on a diagonal. If you remember from way back in the day, 6 sevenths times, let's say 6 sevenths times 9/4. What you could do is you could write this as 6 times 9 over 7 times 4. Then you could rewrite this as 9 times 6 over 7 times 4. See what I did? Reverse the 6 and 9 around because they have the commutative property. Then you could end up saying, well, let's change this to 9/7 times 6/4, and guess what? That fraction reduces. So then you can call this 9/7 times 3 over 2 and get 27/14, and you're a happy camper. Now, this is the very long version of the story. By the time you end up reducing the 6 over 4, you've gone all the way here. Well, basically you're just going to use the property, instead of having the 6 and 9 switch spots, why don't we just allow people to reduce diagonally whenever you're separated by a multiplication symbol, and that's what we're going to do right here with the plus 2's, where the plus 2's are separated on a diagonal with a multiplication symbol, so therefore you can reduce those down. We're just simply left with, no, actually I probably could have done that in the next step. That's right here. This step here is just to show that we're going to multiply across, and we put this together as one big happy fraction. Cancel that, cancel this, cancel that. You're left with x plus 3 over x plus 4. Or we actually could have left this without the parentheses. Either way is fine. Next one, last one. Another multiplication problem. Now again, this one's a little bit longer. As you can see, you might be able to recognize that you have the difference of two cubes. Check out video 127. I believe that is video 127 part C. We have difference of two squares. That's video 127 part B. And then this is going to be factoring by grouping, video 127 part A. Now, this one here, we really didn't do a factoring video on this, but this is very easy. Greatest common factor, take out a 2. Right there, that's easy, you're all set. In fact, actually we did do this in video 127 part A. So here's your difference of two cubes, right here. Alright, factoring by grouping, take out an A, take out a B, right here, C plus D. Then you factor out the C plus D, you're left with C plus D times A plus B, right? There's your factoring by grouping. So just make sure you double check that video. That's probably one of the harder parts of this problem. And of course the difference of two cubes. Once you get to this step here, and you can kind of see how all this works out. Here's difference of two cubes, factor out the 2, difference of two squares, factor by grouping. Once you get here, you're pretty much home free. You're going to cancel out the A plus B's, cancel out the this quadratic. Then you got a diagonal cancel, A minus B, A minus B. Look what you're left with. A C plus D and a 2. And it's really that simple. Right there. You're left with just simply a C plus D over 2. Alright, so if you have any questions or concerns, please send me an email. And of course, good times.